Next example is u is x square tan inverse y by x minus y square tan inverse x by y. Then prove that del by u by del by y del by x is equal to x square minus y square divided by x square plus y square. So u is this, and then del by u by del by x is what? So first, what is del by u by del by y del by x is what? Del by y of del by u by del by x. That is, first find del by u by del by x, and then find its derivative with respect to y. So del by u by del by x, u into v rule, x square derivative of tan inverse y by x is 1 by 1 plus y square by x square into derivative of y by x with respect to x. Y is constant, and the derivative of 1 by x is minus 1 by x square. So u derivative of v, this is derivative of v, then v plus v, this tan inverse y x by y. Don't write here. Here correction is y by x, not x by y. Tan inverse y by x, that is v, into derivative of x square is 2x. So this derivative of this minus y square is constant because derivative is with respect to x, and the tan inverse x by y derivative is 1 by 1 plus x by y square, means x square by y square, into derivative of x by y with respect to x is 1 by y. Okay, 1 by y, derivative of x is 1. So right here y by x, then the correction, the simplification is what? X square is LCM, x square plus y square into minus y by x square, 2x tan inverse y by x. So here is y by x, here is correct, y by x minus y square is LCM, y square plus x square into 1 by y, and then this become x square by x square plus y square, and then x square get cancelled. So we have x square minus y divided by x square plus y square, plus this minus y by x square, this term 2x tan inverse y by x, 2x tan inverse y by x, minus this y square. It is simplification of this factor is what? Y square by x square plus y square, and this y square into y square y raised to 4 divided by y is here is 1 by y. So we have y raised to y square is LCM. So here write y cube. I think here y cube. Don't write here y square, because y square into y square y raised to 4 by y is y cube. So write here y cube divided by x square plus y square, and then we have the here the LCM is x square plus y square. So we have minus x square y minus y cube. Here write y cube. So here is for accurate, that my y cube plus 2x tan inverse y by x. This is del by u by del by x. Then del by u by del by square u by del by y del by x means what? Del by y, that is derivative with respect to u of this quantity. Del by square u by del by y del by x means derivative of this quantity with respect to x. So here is u by v rule. So v derivative of u minus u derivative of v. So derivative is with respect to y. So derivative of this quantity is what? Minus x square is constant. Derivative of y is 1 and minus 3y square. Derivative is with respect to y. Minus then u derivative of v is 2y divided by its square. It's x square plus y square bracket square, right here bracket square, v square. Then plus 2x, that 2x is constant quantity, and the derivative of tan, because derivative is with respect to y, then tan inverse y by x, 1 by 1 plus y square by x square, y by x square, then into y by x, derivative of y by x with respect to y is 1 by x, and then its simplification, this is that LCM is x square plus y square, this 2x square, then we have here is the simplification, take this x square, then what is the simplification? This is the term 2y, take y as minus y as side and sign common, then we have x square plus y square at this place, and the simplification of this term here is like 2x square, 2x into divided by x get cancelled, so 2 by, and then x square multiplied to this x square, 2x square by x square plus y square, right here 2x square by x square plus y square, because this 2x into divided by x get cancelled, and the LCM is x square plus y square, so x square goes at numerator, so right here 2x square, right here 2x square, and then take x square plus y square as common factor, we have this, and then x square plus y square one factor get cancelled. So we have x square plus y square at the denominator, and this is the term minus x square minus y square, and this is 2 plus 2x square, and then plus 2x square minus x square becomes x square minus y square. So this is the answer of this dava u by dava y dava x. Dava, don't write here dava u, dava square u by dava y dava x here, right? Prove that dava square u by dava y dava x. Dava square u by dava y by dava. U is this log of this, and then show that this. So first find dava u by dava x, and then dava u by dava y. Dava u by dava x is what? Log fx rule, 1 by fx into derivative of this quantity. This quantity with respect to x is what? 3x cube derivative is 3x square. Y cube derivative is 0 minus y square derivative. Then here is minus 2xy. Okay. Similarly, the derivative with respect to y is 1 by this quantity into derivative of this quantity with respect to y is derivative of x cube is 0. Derivative of y cube is 3y square. Similarly, here minus 2xy, and here is x square with respect to y. Then their addition is this. Take LCM of this two quantity as this. We have numerator, and then after taking 2 as common, and we have the answer 2 by x plus y. That is this answer, 2 by x plus y. Okay. Next example, u is this, then prove that this. So first show that this is equal to this, and then this is equal to this. That is the proof is in the two part. So first find dava u by dava x, dava u by dava y. Then u is this, dava u by dava x is u by v rule. This is u by v rule. That is v derivative of u minus u derivative of v divided by v square. We have this answer. Similarly, dava u by dava y is what? Dava u by dava y is this. And then consider this, that dava u by dava x minus dava u by dava bracket square. Then substitute the values. Take x plus y bracket square as LCM. We have this, and its square is this. So x square minus y square, x minus y, x plus y. Taking square, and x square plus x plus y bracket square, x plus y bracket square raised to 4, raised to 4. So x plus y get cancelled, and we have this answer. Similarly, consider this 4 into 1 minus dava u by dava x, dava u by dava y, and substitute the values of this dava u by dava x and dava u by dava y. Take x plus y bracket square as LCM, and then x 1 into x plus y bracket square is this quantity as it is, minus effect of the minus on this here is minus, so write minus x square minus 2xy, here write minus 2xy and plus y square, because here is minus sign. So correction is there. Here is minus x square, right here minus 2xy, because the effect of negative sign, plus y square. So correction here is accurate, that minus y square minus 2xy plus x square, then minus x square plus y square get cancelled. So after simplification we have this, and then again we have the same answer, that is this. So from 1 and 2, right, here is this is 1 and this is 2, and from 1 and 2 we say that this equal to this equal to this. Then next example, z is f of x plus ay and phi is x minus ay. Then prove that dava square z by dava y square is equal to a square dava square z by dava x square. First find dava z by dava x. So dava z by dava x means the derivative of this quantity. So what is the derivative of this quantity? Dava f by dava x, dava f by dava x, x plus ay into derivative of x plus ay with respect to x is 1 into 1. Dava phi by dava x, x minus ay into derivative of x minus ay with respect to x is 1. And then dava square f by dava x square is dava square f by dava x square, x plus ay into derivative of x plus ay is 1. And then dava square f by dava x square, x minus ay derivative of x minus ay is 1. Then dava z by dava y is dava f by dava y, x plus ay into derivative of x plus ay with respect to y is a. Similarly, dava f by dava y, derivative of this quantity, and the derivative of x minus ay is minus a. Okay, with respect to y. And then second order derivative is what? Here write dava square f by dava y square, right here dava square f by dava y square. Here write dava square f by dava y square, x plus ay into derivative of it is a, and this derivative of x plus ay with respect to y is a, so a and a square. Similarly, here write dava square f by dava y square, dava square f by dava y square, x minus ay into derivative of x minus ay is minus a, and this minus a and this minus a become a square. Then take a square as common. Here write dava square f by dava y square, dava square phi by dava y square, and this is equal to this quantity, that is dava square z by dava x square. So right here square dava square f by dava y square, here right dava square f by dava y square, and this bracket is the dava square z by dava x square. By using definition of partial derivative, compute the partial derivative dava by dava x and dava by dava. The functions are given at minus 2, 1, at 1, 2, 3. So already these problems are solved in the previous lecture. So solve these problems by using definition. So these are the problems of partial derivative using definition. So this is the definition, and these are the problems. The derivative at minus 1, 0, 3, the derivative of this dava by dava, the function is given. So these are the problems by using definition. Here is also problem. Directly we can solve, but there is the question that find the partial derivative by using definition of partial derivative. So this is the definition of partial derivative. At 1, 2, 3, the function is given. This is 3 variable function, this is 2 variable function, dava by dava. This is 2 variable function at minus 2, 1. So similar to this, write definition and find the partial derivative with respect to x, y, z by using definitions. Okay. So solve these problems. These problems, solve these problems. Find dava by dava x at 1, 1, 1 if this is the function. This is the function is not given, equation is good given. Here is function is given. So there is difference between these two problems. Define z as a function of x, y. Define z as a function. So this is the z is the function of x, y, z. Here if you observe this is the function of x, y, z. That is, this x, y, z are independent. And here it's z is dependent on x and y. Z is the function of x and y. So these are actually 2 variable function. So this equation is given. So there is difference between this problem and this problem. So write this is the equation, and then differentiate this equation with respect to x, because we have to find the dava by dava x. If the question is find dava by dava y, then differentiate with respect to y. So differentiate with respect to x, what do we get? X into y. So derivative of y is itself, because y is constant with respect to derivative is with respect to x. Therefore y is constant, and the derivative of x is 1. Then z cube into x. The derivative is u into v rule, because z is the function of x and y. Z is not independent function. Here is the z is the independent function. How we can find the derivative of this y into z square with respect to y or z? Use if the derivative with respect to y, then y is constant, z square is constant, and then derivative of y is 1. And if we differentiate y into z square with respect to z, then y is constant, and the derivative of z square is 2z. But here z is the function of x and y, and so z cube into x, use u into v rule. Z cube derivative of x is 1 into plus x, derivative of z cube is 3z square into dava z by dava x, because the partial derivative with respect to x, therefore multiply by dava z by dava x. Minus 2y is constant now, and the derivative of z is dava z by dava x is equal to 0. So the derivative of z cube x is what? Is u into v rule, right? Z cube derivative of x with respect to x is 1. Then x derivative of z cube is what? 3z square into dava z by dava x, because z is the function of x and y. Don't use this concept at this place. That is, if I differentiate this with respect to x, then its derivative is 2x, just 2x into y z square. Okay. So here is the derivative of this quantity is with respect to x is what? U into v rule, because z is a function of x and y. At this place, z is not function of x and y. At this place, z is not function of x and y. In this, x, y, z are all independent. Okay. So that is derivative with respect to x, then y and z are constant. Derivative with respect to y in this example. In this example, so what? If I have to differentiate with respect to z, then another variables are constant. With respect to x means y and z are constant. But here is with respect to x, then that z is not constant because z is function of x and y. So take dou by z by dou by x as common, remaining factor to shift to RHS, and then we have dou by z by dou by x is this. And the value at 1, 1, 1 means substitute x as 1, y as 1, z as 1. We have this answer. Similar problem here. The equation is given and x is the function of y and z. Now we find the derivative of x with respect to y as well as z and with respect to x also. But y and z are independent. That is the derivative of y with respect to z is 0 and with respect to derivative of z with respect to y is 0. But the derivative of x with respect to y and z is not equal to 0 because x is function of y and z. And then this is the function xz plus y ln x means log x minus x square plus 4 differentiate with respect to z because we have to find dou by x by dou by z. So x derivative of z is 1. Okay, x with respect to z, derivative with respect to z, x is constant now. X is with respect to z because x is function of y and z. So the derivative with respect to z, so what we have x, z is not now constant because z is function of x is function of y and z, means x is not constant, z is not constant because with respect to x derivative, z derivative. So x derivative of z with respect to z is 1 plus z derivative of x is what, dou by x by dou by z. Why? Because x is function of y and z. That's why we have the derivative of x with respect to z as dou by x by dou by z plus y with respect to z, y is constant. Y and z are constant with respect to z. With respect to z means y is constant. So y is constant and the log x derivative ln x log x dou by 1 by x dou by x by dou by z because derivative is with respect to z and ln x or log x is the function of x, so multiply by dou by x by dou by z minus x square, derivative of x square is 2x dou by x by dou by z because the derivative is with respect to z. If there is z square, then its derivative is just 2z, but it is x square, so its derivative is minus is 2x into dou by x by dou by z is equal to 0. Take dou by z by dou by x as common and we have this answer, and then answer at 1 minus 1 minus 3 is this. Similar problem, here is the problem with respect to 4, answer of 4, this problem at minus 103. Okay, dou by z by dou by x by dou by z. What do we have to find? We have to find dou by f by dou by x at minus 103. So write that definition. With respect to x means limit x tends to 0, f of a plus h b c minus f of a b c divided by h. Okay, write a b c as minus 103 and then write the values of these functions by using this. Substitute x as minus 1 plus h, x as minus 1 plus h, y as 0 and z as 3. We have this value. Here is the value of f of minus 103. Substitute x as minus 1, y as 0 and z as 3. We have this value divided by h and the upper is 0. Numerator is 0. So answer is 0. Then dou by f by dou by y. We have to find first, then dou by f by dou by y, dou by f by dou by y at minus 103. This is the limit k tends to 0. F of minus 1 0 plus k 3 minus. Okay, so this is the definition. What is dou by f by dou by y at ABC? Limit k tends to 0. F of a b plus k comma c minus f of ABC divided by k. Now what is dou by f by dou by z at ABC? Limit L tends to 0. F of a comma b comma c plus L minus f of ABC divided by L. So these are the partial derivative with respect to x, y, z. Then next problem is if resistors of R1, R2, R3 ohms are connected in the parallel to make an R ohm resistors, the value of R is this, and find dou by R by dou by R2 where R1 is this, R2 is this and R3 is this. So 1 by R is 1 by R1, 1 by R2, 1 by R3 plus 1 by R3. and we have to find dab r by dab r2. So differentiate with respect to r2. We have to find dab r by dab r2. So differentiate this equation with respect to r2. And the derivative of 1 by r is what? Minus 1 by r square into dab r by dab r2. Like 1 by x. What is the derivative of 1 by x? Minus 1 by x square with respect to x. Like that, the derivative of 1 by r is what? Minus 1 by r square dab r by dab r2. Okay? Minus 1 by r square dab r by dab. And then derivative of 1 by r1 is 0. Derivative of 1 by r2 is minus 1 by r2 square. Dab r2 by dab r2. No need to write this dab r2 by dab r2. Dab r2 by dab r2 is 1. Because 1 by r2 is function of r2 and we have to differentiate with respect to r2. So no need to write this function. This stuff dab r2 by dab r2. Plus 1 by r3 derivative is 0 because r1 and r2, r3 are constant with respect to r2. Then the simplification is this, and then shift this r2 and both sides are negative, therefore we have positive answer for r2 square, r square divided by r. Then this is dab r by dab r2 and we have to find at the value at this point. So 1 by r is this, 1 by r1, 1 by r2, 1 by r1, r2, r3 are given is equal to 30, r1 is 30, r1 is 30, r2 is 45, r3 is 90. So add this, don't write this, write this step. 90 is the LCM. So 33s are 90, 45 2s are 90, and 91s are 90. So 3 plus 2 plus 1 is 6 by 90. That is, this is the value of 1 by r, 6 by 90. So r is 90 by 6, that is 15 by 2. And substitute here, r square is 15 by 2 square, 15 by 2 square. And r2 square is what? R2 is this, 45, it's square. So 50, here write 15 by 2 bracket square by 45 square, answer is 1 by 9. Here write 15 by 2 because r square, value of r square by r2 square, r is what? R is 1, 15 by 2, it's square, right? 15 by 2 bracket square divided by r2 square, that is 45 square. We have the answer 1 by 9. Next example, if fxy is xy divided by x square plus y square, if xy is not equal to 0, 0 and f of 0, 0 is 0, show that the product derivatives, partial derivative, right here, not product, partial derivatives fx 0, 0 and fy 0, 0 exist, but f is not continuous at 0, 0. Already we have shown that this function is not continuous at 0, 0 because limit xy tends to 0, 0 if xy does not exist, because limit along path y is equal to mx depend on m. So first find the partial derivatives fx 0, 0. So what is fx ab? Limit h tends to 0, f of a plus hb minus f of ab divided by h if limit exists, and fy ab is this. Limit k tends to 0, f of a b plus k minus f of a b divided by k. So fx 0, 0 is what? Substitute a and b as 0. So we have 0 plus h means h, f of a b is f of 0, 0 by h. Then f of h 0. So use this definition. Substitute x as h and y as 0. So we have h into 0 by h square plus 0 minus f of 0, 0 is 0. Directly write 0 minus 0 divided by h. So h into 0 by h square plus 0 square is 0 minus 0 by h. 0 minus 0 is 0 and 0 by h is 0. So we have answer 0, limit of h 0 as is 0. And then fy 0, 0, take this definition and substitute a and b as 0. We have this. Then f of 0k, 0 into k divided by 0 plus k square by using this definition. Substitute x as h, y as 0, x as 0 and y as k. We have this right here, divide by k, this k, and then we have the answer here. This is 0 and this is 0 by k, not k square, 0 by k. 0 by k is 0 and limit of 0 is 0. So both fx 0, 0 and fy 0, 0 both exist, but we have to show this function fxy is not continuous at 0, 0. So when the function is not continuous at 0, 0, either limit does not exist. Okay, so we know that fxy is continuous at 0, 0 if limit xy tends to 0, 0, fxy exists and is equal to f of 0, 0, that is 0. That is, if this limit exists and is equal to f of 0, 0, then the function is continuous. But if this limit does not exist, then function is not continuous at 0, 0. So we will find the limit along this limit xy tends to 0, 0 fxy along path y is equal to mx. So limit xy tends to 0, 0 fxy is equal to limit x tends to 0 f of, right here, f x mx, y is mx. Then what is the value of f x mx? That is, use this formula, substitute x as x and y as mx. So we have this, and then take x square as common, we have this answer. And the limit of this factor is itself, because this is a constant with respect to limit. Limit is on x, which depends on m, and therefore limit along different path is different, and therefore limit of fxy as xy tends to 0, 0 does not exist, and therefore fxy is not continuous at 0, 0. Similar example, the function, the definition of function fxy is this. This is the definition given in 4 parts. When you use this first definition, if x into y is not equal to 0, if this is x is not equal to 0, y is not equal to 0, and this use this last definition if both are 0, so that f is continuous at 0, 0, but fx 0, 0 and fy 0, 0 does not exist. So first we will show that the function is continuous at 0, 0. So when the function fxy is continuous at 0, 0, if limit xy tends to 0, 0, fxy exists and is equal to f of 0, 0, that is 0. So first show that the limit xy tends to 0, 0, fxy exists. So consider let epsilon greater than 0. Already these problems are solved in the first chapter. Let epsilon greater than 0 be arbitrary. Then consider mod fxy minus 0, because answer is 0. We have to show the answer of this limit is 0. Then mod x into sine this, x into sine 1 by x plus y into sine 1 by y. Then by using triangle inequality, we have less than or equal to mod a plus b is less than or equal to mod a plus mod b. Then again separate the mod a into b is mod a into mod b. So here equal to sign, because we have here equal to, here y is less than or equal to, because the of there here is less than or equal to. Then here equal to, separate the mod, and then mod sine 1 by x and mod sine 1 by y. Substitute the values as 1, because as mod sine theta is less than or equal to 1 for all theta, but the value is largest, is upper limit, so like less than or equal to mod x. Substitute the value of this quantity as 1, substitute this quantity as 1, we have this, and this is root x square plus y square. Mod x is less than or equal to root x square plus y square, and mod y is also less than or equal to root x square plus y square. And then this becomes 2 times root x square plus y square is less than epsilon whenever root x square plus y square, shift this to right side, is less than epsilon by 2 is equal to delta say, is equal to, right here, is equal to delta say. And therefore for every epsilon greater than 0, there exists delta is equal to epsilon by 2 greater than 0, says that mod fxy minus 0 is less than epsilon whenever is less than epsilon, whenever root x square plus y square is less than delta. And therefore limit xy tends to 0, 0 fxy is 0, and this limit exists and is equal to f of 0, 0, because the value of f of 0, 0 is 0. So these two are equal. This limit exists and its value is equal to f of 0, 0, and therefore fxy is continuous at 0, 0. Now we have to show this fx 0, 0 and fy 0, 0 does not exist. So what is fx 0, 0? Use the definition, this definition, fx ab is this, limit x tends to 0, f of a plus h comma b minus f of ab divided by h. Substitute a and b at 0, 0. So what is fx 0, 0? fx 0, 0 is this, limit x tends to 0, f of h 0 minus f of 0, 0 divided by h sine 1 by h. So how we can substitute f of h 0? Use this definition, because h is not equal to 0, y is 0. Okay, so x sine 1 by h sine 1 by h, f of h 0, and f of 0, 0 is 0 directly by using this, both are 0, x and y both are 0, so f of 0, 0 is 0, divided by h, and h get cancelled, sine 1 by h, limit h tends to 0, sine 1 by h, and this limit does not exist. No need to write the proof of why the limit of sine 1 by h as h tends to 0 does not exist. It is already we observe in the S.Y.B.Sc that limit of sine 1 by h as h tends to 0 does not exist, and therefore because sine limit x tends to 0, sine 1 by h does not exist. This is the problem of S.Y.B.Sc. So this limit does not exist. This limit does not exist, and therefore fx 0, 0 does not exist. Similarly, fy 0, 0 is this. and then substitute the values. Sin 0k, use this definition, sin 0k. 0k, y is not equal to 0 and x is 0. So k sin 1 by k, sin 0k, value of sin 0k is k sin 1 by k. F of 0, 0 is 0 divided by k, and this limit again does not exist, therefore fy 0, 0 does not exist. Similar problem, fxy is x cube y divided by x square plus y square. X square plus y square is not equal to 0 and f of 0, 0 is 0. Then show that fxy 0, 0 and fy 0, 0 does not exist. So first write fxy ab. So fxy means the derivative of fy fx with respect to y. Either use this definition for this or this definition for this. So fxy, what is the meaning? Fxy means the derivative of fx with respect to y. Means limit k tends to 0, fx a b plus k minus fx a b divided by k. If limit exists. And fyx means the limit of fy, derivative of fy with respect to x. So it is a limit derivative of fy with respect to x, means limit h tends to 0, fy a plus h b minus fy a b divided by h, if limit exists. So either take this meaning of this quantity as fy derivative of fy with respect to x, or derivative of fx with respect to x. So here is the meaning is what? Derivative of fx with respect to y, and the meaning of this is what? Derivative of fy with respect to x. So what is the change? This is the definition of derivative of f with respect to x. This is the definition of derivative of f with respect to x at ab. And fxy means what? The derivative of this quantity. So observe this definition. Fxy means what? The derivative of fx with respect to y. And what is the definition of f with respect to y? The derivative of f with respect to y is this. This is the definition of f with respect to y. And we have to write the derivative of fx with respect to y. Just replace f by fx. So limit k tends to 0, fx a b plus k minus f a b. This is the definition of f with respect to y. And what is the meaning of fxy? Fxy means the derivative of fx with respect to y. Just replace f by fx in that definition. And this is what? This is fy x, means derivative of fy with respect to x. So how we can find derivative of fy with respect to x? So write first the derivative of f with respect to x and just replace f by fy. So then just write a and b as 0, 0. We have this. This is 1 and 2. Then find fx 0k. Fx 0k is what? Fx ab. What is fx ab? Fx ab. Fx ab is this. So fx 0k, that is substitute a as 0, b as k in the definition. So we have this. Fx 0k is limit h tends to 0, f of h a is 0 and b is k. So fx 0k. So f of a plus 0 plus h means h k minus f of 0k divided by h. So fx 0k, how we can write fx 0k? You use this definition. Here is as here is, don't write here fxy, here write fxab. What is fxab? Christ this y. Fxab is what? Limit h tends to 0, f of a plus h 0, 0, right? Here b, right? B fx f of a plus h b minus f of a b divided by h. So write a as 0 and b as k. So we have f of 0 plus h means h, comma b is k minus f of a is 0 and b is k. So f of 0k by h divided by h by using this definition. Here write fx. This is the definition of what? fxab. Then is equal to limit h tends to 0, f of a plus h. So use this definition. Substitute x as a plus h and y as y as k, y as h, y as h. F of fy, the value of f of hk is what? By using this definition, substitute x as h, y as k. We have this minus f of 0k. What is the value of f of 0k? Substitute x as 0 and y as k. We have answer 0. This answer. Then it is 0. And divided by h means h cube, and divided by h means h square. And then take limit h tends to 0, h square, h square, h, substitute h as 0. So 0 divided by k square. That is 0 answer. Similarly, fx 0, 0, fx 0, 0, value of this quantity, fx 0, 0. So use again the same definition, substitute a and b both are 0. We have this. Then value of f of h0 is by using this definition, substitute x as h, y as 0. Minus f of 0, 0 is 0. 0 by h, the calculation of this, 0 minus 0. This is actually h cube into 0 is 0. So 0 by h is 0. Then this value of this quantity, fy h0. So use the definition of fyab and substitute a as h and b as 0. So we have this answer is h. Similarly, fy00, use the definition of fyab and substitute a as 0, b as 0, and we have this answer. So substitute all these values in equation number 1 and 2. Equation 1 and 2. These are equation 1. Substitute fx 0k, fx 00, fy h0, fy 00. All the values are here. Substitute that values. So we have fy, fxy 00 is limit k tends to 0, 0 minus 0 by k, because the value of fxy, this value is 0, this value is 0. So fxy 00 is limit k tends to 0, 0 minus 0 by k. That is, we have 0 answer. And limit fyx00 is what? Limit x tends to 0. Limit x tends to 0. The value of this quantity, equation number, fyh0 is what? fyh0 is h minus fy00 is 0. So h minus 0 by h. So 1, and therefore these two are not equal. Fy00 is 1 and fxy00 is 1. So these partial derivative fxy and fyx are different for some points. So when these 2 points, when these two partial derivatives are same, so there are 3 theorems on these, that Clairaut's theorem, Squar's theorem, and Euler's theorem. That is, there are 3 theorems: Squar's theorem, Young's theorem, and Clairaut's theorem. Squar's theorem, Young's theorem, and Clairaut's theorem. These 3 theorems gives when these two are same, that is Dava square by Dava x Dava y and Dava square by Dava y Dava x, that is fxy and fyx. When these two are same, so there are 3 theorems that are what? Squar's theorem, Young's theorem, and Clairaut's theorem. In next lecture, we will see some more problems of this type and the statements of these 3 theorems, that is Squar's theorem, Young's theorem, and Clairaut's theorem.